Hey, this is Steven from Logitech Tutorials and the Green Engineers, and welcome back to the Green Machine Mill, aka the DIY metal milling machine. And so, what we're going to be talking about today is we're going to be continuing on with this design. Soon, I'm going to be ordering a round of my shredder, so we'll probably go back, and I'm still working on the water jet, so I think water jet's slightly higher priority right now. But once that happens, once that's finished, this is my second priority, and then the third priority is probably a lathe, and then a CO2 laser cutter. Those are my next very high priorities in the list. Okay, so again, we know that we were surprised last time to see that we had a total travel of 13.8 inches, and 13.8 inches, 8 inches. Power head needs to overhang by an additional 4.5628. And actually, I just bought a brand new caliper. I have my regular caliper here, my just cheap Harbor Freight carbon fiber digital caliper right here. And then one of my calipers I've had it's been my go-to. It had a couple issues. So that guy is now going to be my stay home. And I bought a Shars Ventor 67, IP67 rated. So it's good around coolant and stuff like that. And so that's going to be my normal shock calipers. And then these, which are my eye gauging, Absolute Origin, are now going to be my home calipers for measuring. And then I'm going to use these carbon fiber calipers just for rough measuring. They are plus or minus 10. Actually, you know what? I wonder how much they're off. Let me check that really quick. I have this Lego right here. 124. And I believe I fixed it, but now, I can't really trust it as much anymore because I don't know, how off it is. Because it could be off. So this is 124.4. So obviously this one only goes up to a tenth of a thousandth or the hundredths place instead of the thousandths place. So obviously it's 1244. So, and I do really like this calipers. I'm gonna figure out what channel I plan on reviewing those on because I do believe that they are definitely a lot of help on these types of things. So maybe on this channel. I might go into tools of designing, obviously calipers, depth gauges, stuff like that. Maybe it's even a scanner at some point, but obviously I don't even have that. In a printer, what type of printers to look at, etc. Anyways, so we have a additional 4.5628, and so it does look like these calipers are indeed pretty precise, and they have a nice contrast and a big screen, but not the best for measuring because they don't do thousandths. So for looking at things like that, not the greatest. 4.56. I can't even do the 2.8. So, but that is a lot of space. Oh, and by the way, after that last video, I did look online and I found in China that they have a 3,000 watt power supply for about $300. Now, 300 watts, because if you guys remember, 3,000 watts. Because if you guys remember, we were looking at, okay, so that's 4 horsepower. Right, and I think this power head, what was this power head rated at? Actually, at 3,000 watts or 4 horsepower. And that other one was 48 volts times 70 amps, which is 3,360 watts, which divided by 750, obviously a little bit over 4 horsepower, it's about 4.5. So obviously we would need something bigger than that 3,000 watt to run the rest of the motors. So maybe even a 4,000 watt power supply. I'm thinking even maybe like a big battery bank or something. But the next up, the transformer switching power supply. Oh, these are 12 volt. Ooh, that's too low. Oh. This one, like that one right there, this would be perfect. Oh, it includes free shipping. So, oh, and then this is probably no. What is this? This is 2,500. This is 4,000 watt. So something like this. Power. Position negative. These are the three. Oh, it has to be 220. Okay. Voltage adjust. So you get exactly 48 volts. You have a fuse here. Cool. 48 volts, 83 amps. So that means that we have an additional 13 amps that we can push at 48 volts. So 48 times 13.3 equals 600 and but then again it's 3,000, so we have another 1,000 watts divided by 48 volts. So we can push another 20 amps. 20 amps for everything else. And then so obviously that's another, so for the 3 additional motors, so 1,000 watts divided by the additional split within the next 3 motors divided by 750. It's about half horsepower each axis. And again, that's assuming that we're not pushing the spindle at max power, which is 4 horsepower, which obviously isn't needed. I mean, we definitely don't even need that ceiling. Probably go with that. The other one I was looking at was like 400. I mean, it could be basically what the 1100M is, which is a 2 horsepower, which that's only 1,500 watts. So, and then if we use another 1,500 watts, everything else, we'd use $300 power supply. I really don't think that we need to go up to this 4 horsepower on this guy. Anyways, so let's go ahead and look at what we could do to get that extra step over. And again, I still haven't gone in and changed these yet, but we don't necessarily super need that right now. And for this guy, I would definitely go and consult with maybe the Highwind guys to figure out, what to do here. Obviously, I could machine something and stick it in here to hold the bearing and to hold this guy, and then have this guy stick out over here somewhere, and then have this go up to this, and then the bearing in here with some support, and then 2 holes drilled down here, and then screw the block in there. And then same deal here. This guy go over here, and then I could consult with them about them telling me what to do there, because I believe they're just regular steel. So even if I had to cut it and turn it down, that's fine also. It doesn't really matter. But obviously I don't want to pay extra, and then that's increased machining time that I don't necessarily need. So, and then like I said, this needs to go up a little bit. This needs to go up a little bit because we have this, because we need these pieces to clear. Or you know what we could do is come in and recess that 1/4 inch a little bit so it sticks out. It's not that big of an issue, and that will leave more meat. Actually, we'll bring these up. It'll leave more meat in here, anyways. So that looks good. Let's go ahead and look at. And again, this is kind of because again, this is touching right on. I guess this is the seal piece, so technically that will be that way, but it might be taller or shorter. I'm gonna have to ask them about the tolerance. So, and again, here we are at properties. We're at 9,646 ounces divided by 16 ounces per pound, 602 pounds. Okay, so now we need another 4.5628. So now the question is, so a 2 horsepower spindle, including VFD, it's a 2400 watt spindle. And then so obviously we need to step it down quite a bit, and obviously it's got way more bearings than we need. Because really we don't need a spindle, we just need some sort of... that's not going to work. Let me bring this over. Oh, it's the same way. There you go, treadmill motor. So it looks like it just goes here, but I do like this idea. So a treadmill motor, that's interesting. Where'd that go? That was there or something. That's only 1/2 horsepower. Hmm. best is probably to use the spindle motor. I mean, we could design for that right now. Pretty much what we'll do right now is... Because DC, I'm not going to do just a regular... I'm not going to do just a regular treadmill motor that's already DC if I could, you know... What if I do AC 2 horsepower motor? So yeah, again, it's giving me the treadmill motor. But that spindle motor will give us a lot of power. But again, we don't need all those bearings in there. Okay, what about 4 horsepower motor? Anyways, so 4 horsepower AC motor's not coming up. Anyways, so let's keep going regardless here. So right now let's pretend that we're gonna use a spindle motor, or some other something off of off of like a vacuum cleaner or something. And then driving this guy, because this guy's the guy with all the good bearings in it, and we don't need to pay for 2 things with 2 different bearings in it. So let's look here. So again, we need 4.5 something. So let's just do that. And it's going to be the same size as this guy here. Which is 9.843. So basically, it's going to be this way. Let's do 4.5628, and then width 5.197, 5.197, and then height again is 9.843, 9.843, 9.843. And then let's punch a 60 millimeter hole in it. 65 millimeter hole. Just for accurate representation. And then that's plenty of enough, area to really suck all the energy out of that spindle, and a lot of support. And again, so let's look at the 4 horsepower spindle. It's 3,000 watt spindle. 3 kilowatt spindle with inverter from China. Oh man. But this thing's kind of cool. $380-volt. Well, I guess if I'm going to buy a spindle, I might as well buy this one, and then later on when I want to use a different one, when I want to go to the other system, I could just pop this on some other machine, pretty much, onto a router of some type or whatever. Ooh, this is 100 millimeter. Oh, that's a nice one. How big is this one? Oh, so 4 horsepower, they want 100. I don't know if 100 will fit. Ooh. It's about 3/8 on each side. That's a little bit of meat. These are... What about, I don't know, plus I don't want to go right up to that rating, that 4 horsepower rating. So let's drop it half. So give it a little bit. Yeah, so these are 80s. So a 2 okay, so they're 2.2, which is, yeah, 3 horsepower. And I can run off 110. Or 220. I have 220 in the garage, but I don't have 380, so I can't run 380. So let's say that. So let's say 60. Or these are 80 millimeters. So these are 80 millimeters. There we go. That's better. That's a decent sized spindle. Okay, so now with that, let's say how long it is. Oh, here we go. Perfect. Look at this. Nice. You could do 220 or 110. Ooh, runoff less than 0.005 millimeters. ER20, 80, 230, CNC engraved for fork bearing, 2.2 kilowatt, diameter 80. Total length sticking out is 12. Okay, so let's use calculator here. 12 plus 13.5 plus 191 plus 28 equals. But there is one issue, and that is that this is going to have to be facing up, and then we have the cable coming out. We'll have to do something about hiding the cable, getting the cable out of the way, so this thing gets really, really close to the table. But I think that that's not going to be that big of an issue. We could probably jerry rig something, even a 3D print something that goes in there. Current 8.5, speed 2400. So obviously we need to step that down 4 to 1 or higher. Okay, but basically that's 244.5 millimeters. 244.5 millimeters. Oops. $244.5. Oh, look at that. Just under what we need. I think this is what, 9.6 something. Yeah, perfect. Okay, so let's design this here. We have 6 minutes, so let's design this as this is one of the first options, I think. Okay, so let's say here this is 25 millimeter circle. 25 millimeter millimeter circle, 38 millimeters tall. Then you have a smaller circle. It doesn't say exactly how big it is, but it's slightly smaller than the overall. I'm going to say it's about 65 millimeters. And then that is 12 millimeters tall. Oops. Oh, this is the 4 bearing type. I mean, it makes sense. I guess it's definitely a interesting idea about using it later on another application. This is 13.5 millimeters. And then this is going to go 191. And then this is going to be 28. Oh, this is water cooled. Oh, 80 by 230. I wonder why it says 230. Anyways. Well, we might go directly with a with that other system, but you're gonna be in it big dollars. I would like to be making money with the system first before I do that, and then we could work on the brushless setup with, and then we'll start working on tool changer on the side while still using this guy, because you're gonna need a tool changer in order to do it, unless you get the spindle go really slow, hit an end stop, and then use the brake by hitting the dogs, right? If it was a R8, it wouldn't be an issue, but it's not an R8, so that's not going to work. So this is, let's go ahead and, where'd he go? Where'd he go? Is this guy? No. There's guy. But this is, what is it? 272.71. It comes with a water pump. Again, I don't think we need water, but I guess the thing with the water is it keeps everything at a constant kind of, and just use a 75 watt water pump, but still. And then it uses a small little connector. Okay, so this is the 2.2 kilowatt, 3 horsepower, 80 millimeter spindle motor. Uses an ER20. Nice. I mean, it's going to be roughly completely solid on the inside, most likely. So now, and then probably steel or aluminum of some type. It looks like possibly aluminum. Let's see if it says here. It says run out less than 0.005 millimeters, which is really small. 0.005. That's 2/10. So it'd be great for engraving after. Water pump, clamp, features of the clamp. 4, a 6, and a 3.175. ER20 call it. Does not have weight. Anyways, so let's go ahead and let's put it all together in this next minute or so. We are already over time, but that's okay. Oh, but this piece is actually going to have to be bigger. It's actually going to have to be this wide. Basically from here. 7.291. 7.291. There we go. Maybe even at some point, if I wanted to sell that spindle, it'd still probably be okay because I mean it's basically not taking much load. Okay, so we got that there. And pretty much I'm going to go back here and hit this guy. Hit this guy here. Okay. Looking good. And then we're going to drop our spindle in there. Something does not look right there. This is not in the middle. That's okay. I mean, it looks like we did something wrong here. We'll do the math right before we leave here as it's getting close to where I usually hit the sack. So it's 12:40 at night. Oops, wrong way. Okay. I forget that it's not actually pointing down, it's actually pointing up. Just like that. And then probably some sort of cover, 3D printed cover or something over this thing. Okay, but this is definitely not in the center here. Because this guy's got to be way over here somewhere. So again, the full travel, let's go back and look at that again. Total travel of the system is 13.85. So 13.85. Okay, so we're there. We're in the right spot, so I did my math wrong here somewhere. Because this is going to travel further. Because basically what it's going to do is it's going to travel half of that. So this is going to go this way. And this has got way more than 6 inches here. Just on the model, it just doesn't look right. Okay, so let's double check this here. So negative 1.9. Negative 1.90. Take that. Plus 15.8 is 13.9. So this other one off by 50,000. So, okay. So basically that head has to be in the center of that. Six point nine, 2.3622, 4.5878. Okay. Okay, so let's do that. Negative 1.9. And then what we're going to do is let's go ahead and drop the head really quick and see what happens. So obviously we have an issue because basically it needs to be another half of this head, another half of this travel. It looks like it's directly over. So pretty much it needs to stick out an additional half here. So 14. So okay, so it needs to stick out an additional 7 inches. Okay, so basically we're going to go in here, spindle mount. And what I'm going to do is I'm just going to add 7 inches. That's a big boy. What are we talking about now as far as weight, properties? That's almost 3,417 divided by 16. Oh, 16. It's about 200 pounds. Yeah, probably gonna have to make that one out of aluminum. But we're way over time now. Almost 40 minutes. Oh man. There we go. Now it should be at the edge of the table. So let's drop it down. Yeah, there we go. And now I'm curious also about what's the maximum travel we could get here. Negative. Okay, so basically that's it there. Perfect. And it's a little bit past the head, but now that looks good. Alright, so now we got it. Obviously, we're going to be way over what it's actually going to be because, again, I don't want that spindle head to weigh 200 pounds because we also need to counterbalance this thing. So it's probably going to have some sort of pulleys that go in here and hold this thing up. So that's another thing that we're going to have to do. Or it's going to have to be shock held. It's probably going to end up being shock, just because we don't really have a lot of space here. Similar to what you see on the Skyfire. So this is one right here. It says 1.35 times 4 times 10 to the 4. 1. So 1, 2, 3, 4. So 13,450. So that's 1, 2, 3, 4. Yes, divided by 16. Talking 840 pounds. Okay, I mean that's livable. All right, so we are almost in the 1,000 pounds just for our machine. That's looking good. I think 1,000 pounds would be a good place to be. All right, so this has been Steven from Legit Tech Tutorials and the Green Engineers. I'd like to thank you guys for watching. If you like this video, please subscribe for more videos like it. I'll see you guys next video. Take it easy. Peace.